Yeah. Oof. We're glad you're here. Okay. Suppose I have a 35-degree angle and a side of length 10, and I have another side of length 8. Today, this is a situation that we want to investigate. I'm going to do my best to explain it. Unfortunately, generally only about 30% of people fully understand what I talk about, but it's still important. Some of you might have to watch a video a second time. Some of you might need to read your textbook. I know that sounds scary, but the textbook is actually wonderful. It's great. It does a great job of explaining stuff. So here we have it. We got 10, 35 degrees, 8. Everybody agrees this is side-side angle? Yeah. If the angle was between the 10 and 8, then it would be a side angle side. But this is side-side angle. Now, the reason why I didn't draw the side totally completed on the bottom is for this case right here. You can see that I have 10 and I have 8. And if you follow the decision tree, it says that if you consider the side opposite the angle, is it longer than the other given side or is it shorter than the other given side? And yesterday we did all the ones that were longer, right? But today, you look, you can see it's shorter than the other given side. That could end up with a no solution scenario, or that could end up with a two solution scenario. And so we want to investigate that piece right now. So if you examine this, it says that the side opposite the angle is shorter than the other given side. Watch what I can do. This is the best way to view it from a geometrical standpoint. I got 8. Watch what I can do with this. I can not change the length of 8, 10, or the angle of 35. Neither one of those will change. And I'll create a new triangle. Do you agree that that new triangle also has a length of 8, a side of 10, and an angle of 35 degrees? Exactly. So that triangle does, and so does that triangle. Because you swing on the pendulum this way, you can see that you get two different triangles. So there are two different solutions. Why the heck is that? Well, there's some trigonometry that's involved there, and it starts with this piece. I'm going to call this angle B, angle A, angle B, and angle C. Tell me something about angle C. Is it acute or obtuse? It's acute. What does that mean? It's less than 90 degrees. So I take that guy and I swing it over here to create my other triangle. Now is angle C acute or obtuse? It's obtuse. Here is acute. Here is obtuse. Acute, obtuse. Which one is it, and why can't we tell the difference? Well, it has everything to do with how you set up the law of sines. For example, if we were to set up the law of sines and say sine of 35 divided by 8 is equal to the sine of C over 10, and we were to cross multiply and solve, we just simply multiply both sides by 10 in that scenario, right? We get 10 sine of 35 divided by 8. And what do you get? You get 0.71. Is that value positive or negative? Positive. Where is sine positive? Which quadrants is it positive in? The first and the second. Well, where are acute angles? Are acute angles in the first quadrant or second? An acute angle is in the first quadrant, right? How about obtuse angles? They're in the second quadrant. But sine is the y value. Well, don't these spots have the same y value? You see, sine can't tell the difference between an acute angle or an obtuse angle. So when you do sine inverse here, watch this. I'll do sine inverse, and I get 45.80. Sine of 45.80, we should get that same thing. But watch if I do this. Sine of, I'll try an obtuse angle, 134.20. And I get, what do you notice? Yeah. And so it's like, hey, sine of 45.8 gives me that, and the sine of 134.2 gives me that. But when you sine inverse 0.71691, 1,06077, it only comes up with one result. It only picks out the acute angle. It doesn't pick out the obtuse. And that's why you got to set up two triangles. So in this scenario, we got triangle 1, and we've got triangle 2. Both that have measurements of 8, 10, and 35 degrees. That's why donkey causes a problem. All is centered around that idea and sine's inability to pick out the first or second quadrant. Let's look at a different situation. Suppose we have the same type of setup. I've got a length of 10. I've got an angle of 35 degrees. And instead of a length of 8 on the other side, we're going to create a length of 2. Okay? So I'm going to create a length of 2. Ooh. What's the problem with the length of 2? Yeah, it really doesn't reach, does it? I mean, it's just dangling up there, right? Just a short little side. There it is. Poor guy, right? So let's set it up. Say you have the sine of 35, and you divide it by 2. That's equal to the sine of b divided by 10. Watch what happens here. You cross multiply, and you move the 10 over here. You've got 10 sine of 35 divided by 2. And you come up with 2.86. How do I solve for b? What do I do to both sides? Sine inverse. Sine inverse the answer, and you get, oh, what happened? I got an error. Why? 2 is too short. How do you know that? Well, think about it, folks. You just got done graphing sine and cosine, didn't you? We just took a test on that. What was the period of sine? 2 pi. What was the biggest value of sine? 1. What was the smallest value? -1. Sine at most is 1, and at least is -1. Can sine be a value of 2.86? No way. And we just learned about that, didn't we? So you try that. Any value, you say sine of, or sine inverse. Ashley, give me a number bigger than 1. Anything. 7. Sine inverse to 7, you're going to get an error. Sine inverse. Willie, give me a number between 0 and 1. 0.8. You choose anything between 0 and 1, it's going to spit out a value for you. See the difference? So in this situation, we say no solution. Geometrically, what's happening? It's impossible to have a length of 2. It's just too short. Won't work out. We have one more scenario that comes up. That's the scenario we dealt with yesterday. Suppose, again, you have this length of 10, and you have an angle of 35 degrees. But instead of the side opposite being shorter than the other given side, suppose it's longer. I know what you guys are thinking. You're saying, well, Mr. Gantz, we just swing that thing on the pendulum, and we'll come up with another triangle. Well, if you have one that's longer than the other side, watch what happens if you try to swing it on the pendulum. I got it here, and I swing it on over here, and it just totally undoes the 35-degree angle altogether, doesn't it? So you can see it's impossible to create your second triangle. And some of you guys were like, well, you could do, you just, there you go, there's another triangle. Well, what happened there? Yeah, I lost my length of 14. All of a sudden, that one's going to be shorter than 10, isn't it? So that's the issue that we come up with. There's also another type of situation I just quickly want to bring up, is this one right here. Suppose you have 150 degrees, you have 10, and you have 4. I want you to look at that triangle for a second and tell me anything about it. How many obtuse angles can a triangle have? Only one, right? So if this is the obtuse angle, then the side opposite has to be the largest side in the triangle, right? And it's not. So this triangle is an impossible triangle. There is no solution for that. So understanding these is extremely important. The problem is when you set this up, and you go sine of 150 over 4 is equal to the sine of b over 10. The problem is when you type in 150 to your calculator doesn't understand the difference between obtuse and acute. So it treats it just as though it's a 30-degree angle, because the sine of 150 is the same as the sine of 30. They're both 0.5. Okay? So let's begin the diagnosis. 3 problems. We'll see them through, and you'll have time to work. I have a triangle. A, B, C. It says solve the following triangles. Begin by classifying which one of the 5 cases it will be. I say 5 cases because we're not going to do any of the angle, angle, angle. I have A is 42 degrees. Side A is 22. B is 12. So, does everybody agree this is a side-side angle? All right. I know it's the donkey situation. I immediately need to go to my flow chart. And my flow chart says, decide, is the side opposite the angle longer or shorter than the other given side? Which one is it? It's longer than the other given side. And so therefore we can be confident that there is just one solution using the law of sines. So, good news for us. We don't have to worry about 2 solution or no solution. Let's solve it. I've got A is 42 degrees. I've got B is 12. And I've got A is 22. Sine of what? 42 over 22 equals sine of B over 12. Easy way to solve this is to multiply both sides by 12. 12 sine of 42 divided by 22. And I get 0.3649. Is it possible for sine to be a value of 0.3649? Yeah, because sine has to be between -1 and +1. So we know it's a reasonable solution. We will sine inverse that value, and we come up with 21.41 degrees. What's the next part of the triangle I'll need to solve? Angle C. How do I do that? They all add up to 180 minus 2141 minus 42. I get 116.59. Find side C by using the law of sines. Sine of 42 over 22 equals sine of 116.59 over C. Raise your hand if you did at least 3 of your problems from your homework yesterday. Good for you. Hopefully you became quick with your work and you understand how to solve this then quickly. I will multiply 22 and the sine of 116. I'll divide by the sine of 42. And done, 29.40. I'm going to check the reasonableness of my solution. Biggest angle, C. Is my biggest side C? Yes. Smallest side, A, or smallest angle, B. And that's small side as well. So it looks like my answer is reasonable. We all okay? So I can't pick up what we did yesterday. Let's move on to the second situation. I have another triangle. A, B, and C. A is 85 degrees. Side A is 15. Side B is 25. Angle A is 85 degrees. Side A is 15. Side B is 25. Everybody agree it's side-side angle? It is side-side angle. So I go down to the decision tree. Decision tree tells me, is the side opposite the angle longer than the other given side or shorter than the other given side? It's shorter. So I am either in a two-solution scenario or a no-solution scenario. You don't know until you set it up. People always get to this point. They're like, Mr. Gantz, which one is it? And I said, figure it out. Let's set it up. Sine of 85 over 15 is equal to sine of b over 25. Multiply the 25 on over. 25 sine of 85 divided by 15, I get 1.66. And Sam said what? Why? It's bigger than 1. Sine can't be a value bigger than 1. If you try to inverse that, notice what you get. You get an error. It doesn't like it. Okay? You're worried you made a mistake. Well, what it tells us is that we drew a triangle that was impossible. There's no way we could connect this 15 all the way down the other side. It's more like that's the length. It won't reach. It's impossible. Now, if this wasn't 85 degrees, let's say it was maybe 65 degrees, then maybe it would reach. Okay? Or maybe we have to drop it to 55 degrees. The point is that this is an impossible triangle. No solution. Your work is done. You like that? Yeah, you do. We love no soul, right? It's all about that. No soul. So let's consider the last scenario. One more triangle, A, B, and C. Side A is 12, side B is 31, and angle A is 20.5 degrees. Everybody okay? All right. Everybody agree we're at side-side angle. So now, is the side opposite the angle longer or shorter than the other given side? It's shorter. That means it's either two solutions or no solution. You want to know right now. You don't know. You have to start to work out the problem. It says, when solving for the missing angle if sine is greater than 1, there's no solution. That was our last situation, right? This one says, when solving for the missing angle if sine is less than 1, then there are two solutions. So we have to start setting up, see if we get a value greater than 1 or a value less than 1. And that will tell us the nature of our solution. So we have sine of what? Divided by equals sine of b over 31. 31 sine of 20.5 divided by 12. 0.9047 is equal to sine of b. What does that mean? That means you have two answers. And here's what people do. They often just solve the first triangle. Don't. Look at your decision tree. What does it tell you to do? It says sine is less than 1. There are two solutions. At this point, set up two possible triangle solutions. Do it right now. So we're going to take our triangle and we're going to set up a second one. I've got one right here called triangle 1. Got another one here called triangle 2. So we got A, B, and C. A, B, and C. The 20.5 stays the same. That was given. The 12 stays the same. That was given. And the 31 stays the same. But right now, what angle am I solving for? B. This is what ties the two together. The decision tree tells you what to do. It says, Triangle 1 will have theta or your angle be an acute angle, and triangle 2 will have theta be an obtuse angle. To find theta, use sine inverse. So I'll do that. Sine inverse of my answer, and I get 6478. So I'm going to go to my solution, and I'm going to do 6478. Is that acute or obtuse? It's acute. How do you find the obtuse one? What does it say? Yeah, I take 180 minus it. That's what the decision tree says. So I go 180 minus that guy, and I get 115.22. That's what ties the two triangles together. It's the only thing that ties the two triangles together. Notice again, if you took the sine of 64.78, you get that thing. If you take the sine of 115.22, you get that thing. It's the same exact value because sine doesn't know the difference between first and second quadrant. Well, now it's a piece of cake to solve. How do you find angle C? Yeah, you just solve these independently. So we'll focus on triangle 1 right now. We got 180 minus 64.78 minus 20.5, and I've got 94.72. And for this triangle over here, I'll have to do 180 minus 115.22 minus 20.5, and I get 44.28. So how would I find side C? Law of sines, right? And this C, I would also use the law of sines. Boys, I want you to solve triangle 1, side C, use the law of sines. Girls, law of sines, find C for triangle 2. Go. See what you come up with. If you want to check the reasonableness of your solutions, we got B is the biggest angle at 115, and B is the biggest side at 31. You got A is the smallest side at 12, smallest angle at 20.5. That checks it out, but you have to list both two triangles as solution. We're going to read the decision tree. We're good to go. You ready for an assignment?